In this video, we'll introduce radical expressions and some of their properties. We'll evaluate some radical expressions or roots, and we'll talk about the domain of these radical functions. So a radical expression is any expression that contains a radical symbol. It might look something like this. We read this expression as the nth root of a. N is called the index. That indicates what type of root we're taking. And a is called the radicand. Taking an nth root in a lot of ways is the reverse or inverse of taking a power, and we'll see that as we evaluate some of these examples. There's one more important part of this definition or a property that we need to remember. If the root is even, the radicand must be non-negative. It must be greater than or equal to 0 for the expression to be defined. And this impacts the domain of some radical functions, which we'll see in later examples. Let's evaluate some roots or radical expressions. Notice that in these first few, there's no index given. This is assumed to be a square root, or you could write in an index of 2. If there's nothing written there as an index, it's an index of 2, which means a square root. So evaluate the square root of 25. Square root of 25 is 5. And I'm going to give a reason for this. It's because 5 times 5 equals 25. So you see how this is the reverse of taking a power. If I square the number 5, I get 25. This is going backwards. If I take the square root of 25, I get 5. Now technically, there are two numbers that could be the square root of 25. Because if I square 5, that equals 25. So 5 squared is 25. But it's also true that negative 5 squared equals 25. This would be negative 5 times negative 5, which would also give you positive 25. So which is it? Well, this root symbol always indicates a positive root, square root. If the negative square root is desired, there will be a negative sign in front of the symbol like this one. So the positive square root is called the principal square root. You always give a positive number there if you're working with square roots. If they want the negative number, you indicate that with a negative sign before the root. So the negative square root of 64 equals negative 8. The negative sign is just transferred over here, and the square root of 64 is positive 8 because 8 times 8 equals 64. Now what about this one? The square root of negative 16. This one is undefined because if you think about squaring a number, we cannot square a number times itself to make negative 16. If I put positive 4 in here, 4 times 4, that's positive 16. If I put negative 4 in here, negative 4 times negative 4, that's still positive 16. So there's nothing that equals negative 16 when you square it. That means the square root of negative 16 is undefined. It's not a real number. You can express it using complex or imaginary numbers, but that's beyond the scope of this course. So we'll just say not a real number or undefined. However, that changes when we go on to a cubed root of a negative number or any odd root of a negative number. The cubed root of negative 8 is defined. It equals negative 2. And the reason is because negative 2 times negative 2 times negative 2 does equal negative 8. So we can multiply a negative number an odd number of times to equal a negative. Because of that, the negative roots of odd indexes are defined. They're just negative numbers. So I can take the cubed root of negative 8. I can take the fifth root of negative 32. That's perfectly fine. Those are negative results. I can't take an even root, a square root, or a fourth root of a negative number. All right, so even roots of negative numbers are undefined. We want to remember that. One more example. This indicates the square root of x to the fourth. So we have to think about what would you square multiplied by itself to make x to the fourth. And the answer is x squared. So the square root of x to the fourth is x squared because it takes x squared times itself to equal x to the fourth. Finally, let's look at an example of finding the domain of a radical function. Here it's the square root of 3x plus 5. We have to remember that property we saw earlier. If you're working with an even root, a square root or fourth root or sixth root, the radicand cannot be negative. If the radicand is negative, if this amount is negative, then the root is undefined. So that impacts our domain. I just look at the radicand, which is 3x plus 5, and I say it is non-negative, which in math symbols means it's greater than or equal to 0. I've just set up an inequality here that I can solve for x. So 3x plus 5 is greater than or equal to 0, which means 3x is greater than or equal to negative 5. Let's divide by 3. That means x is greater than or equal to negative 5/3. So there we have it. That's our domain. It's any value that's greater than or equal to negative 5/3. Here it is as inequality. I could write it in interval notation as well, writing it like this. The interval, the domain goes from negative 5/3 to positive infinity.